Today we're going to be talking about the independent samples t-test. The independent sample t-test is different than the other tests that you performed last week, the one sample t-test, in that the sample, there are actually two samples. They wouldn't call it a two sample t-test because there's a study called that you'll be doing next week, which is called, or in 2 weeks, that's called the paired sample t-test. Independent sample t-test is just an advancement of the one sample t-test in that you'll be looking at two means rather than just the one. There is no criterion number. That's the other factor. For the independent sample t-test, it will give you two means that you'll be studying, but the variables that you'll be looking at will be separated. They won't be, it won't overlap in any way. They're exclusive categories. Some of these variables will be male and female, yes and no, or any other variable that can't overlap that will end up having two. So let's say you're working on socioeconomic and you have upper, middle, and lower, and nobody answers in the upper category. Well, you have middle and lower. Which would originally been an ANOVA, because it's three or more, which you'll be working on in a couple weeks, you now have only two, middle and lower. So within that respect, you turn around and change it into independent samples t-test. You could run two separate one sample t-tests, but you really don't have the criterion would then be the mean. But then to compare them and get a value, it would not be a valid test. So when we look at the difference, you can see here in the middle, the difference is more likely to be meaningful and real if the differences between the averages are large. The sample size is large and responses are consistently close to the average values but not widely spread out, so the standard deviation is low. These tests are relatively straightforward and simple. You're examining the means and you're examining the p-value. The t-value and the p-value will come up later. Please take a look at this example. It's a very simple example, and it will give you a lot. We're also going to deal with the effect size a little bit today. How are t and p related? The t value you reported last week, that's the number underneath the letter t on the SPSS, and the p, we talked about, that's the probability that it will happen by chance. Okay, you have learned that t-test produces a t-value, which is converted to a probability. The probability, of course, of it happening by chance, which we call the p-value. You may wonder why we just don't report the value of t. The main reason is the p-values are much easier to understand. The p-value answers the question, if my null hypothesis is true, what is the probability of getting a t-value of at least as big as mine? It tells the probability of seeing the difference you found or larger due to the sampling error if there isn't really no difference. It doesn't mean all of the extra interpretation that the t-value needs, such as knowing how many degrees of freedom or tails there are. It's worth noting that that is not the probability of the null hypothesis being true. It is specifically the probability of seeing a difference at least as large as yours between the two samples in a single population where there is no difference. One of the things is as the t's value get bigger, the p-values get smaller. T-values can be negative, but p-values are always positive. The p-value for negative t-value is the same as the positive version of that t-value. A two-tailed test will provide a p-value that is twice as large as the one-tailed test will produce. A two-tailed test requires a higher value of t to produce the same p-value as a one-tailed test. Now remember, the two-tailed test is in the normal distribution. It would mean that the tails at the very end, not the upper portion, but the tails at the very end, they're equally distributed in a two-tailed test because you're looking at one tail or the other. If you're picking one tail, you either pick the right side tail or the left side tail. the effect size, Cohen's D, okay? If there's enough data, the difference between these two groups will be statistically significant, but the effect size would show that they're not practically relevant. A t-test effect size indicates whether or not the difference between the two groups' averages are large enough to have practical meaning and whether or not it's statistically significant. Okay, so you're going to get a p-value, but then you're going to have an effect size. Okay, the effect size is real important to understand if that difference is large. The p-value would give you some idea if it's statistically significant enough. But if the difference is not large enough, then you probably would not report this in a study or anything like that. You have data. You always come out with some kind of data, but you really don't know the difference. Here is the, for Cohen's D, here is the actual, formula for it. And it's very simple. You have the mean of group 1 minus the mean of group 2. Very simple. The SD pooled. Okay? And here how you do this. You basically, this is how you get that SD pooled. SD squared of group 1 against SD squared group 2 divided by 2, and then you do the square root of it. And it'll give you then it will give you Cohen's D. Okay? This one would turn out to be 0.88. There's lots of different ways of doing it. For me, it's 2, 5, and 8. It's very simple. So if it comes out to be either 0.2 or under, it's small. 0.5 or medium, it's medium, and 0.8 would be large. There's it goes from small to big, and honestly, when you have a number like 0.88, it's very large. There was a large effect between those. The effect size will be large if the absolute difference of the averages is higher, like $5 instead of 3 cents. Responses are consistently close to the average values, but not widely spread out. The standard deviation is low. And then there's another example for you to read about. Here's another example for you to look at. We've already talked about hypotheses testing, but we're going to talk about it again. But, of course, hypotheses is all about a claim that you're going to make. You're going to either have the null or the alternative. Bottom line is the null means there is no difference in it, and the alternative means there is a difference. Okay. Method, we state the hypotheses, we set the criterion for the decision, we compute the test statistic, and we make a decision. This is important for your midterm. The scientific method is very simple. It's very straightforward. Okay. The easiest way for me to explain this is, in this class we don't really do hypotheses, but in a regular setting you would set the hypotheses. Let's say if we were looking at knee injuries and certain modalities, we would take the criterion to be set up for the hypotheses of there would be no difference in knee flexion by doing this modality for the null, and then the alternative would be there would be differences in the effect of knee injuries when we are using this modality. We would then compute our data, and then we make a decision whether we are going to accept the null or reject the null and accept the alternative. And for the test statistic, the p-value, we've discussed this before. Keynote. 0.05 is the standard. It is a level of confidence. 90% of level of confidence, we basically it would be P would be greater than or less than 10%. Okay, 95% level of confidence would be we move down to 0.05. So P is greater than or less than 0.05. And then 99%, and you'll see this a lot in your research studies that you're looking up, would bring it to 0.01, which would be 1%. So it would be P is greater than or less than 0.01. Remember, non-significant would be above that number, and significant would be below that number. And 0.05 is the standard. This is a picture of the actual process. You find a population, you set the level of significance. Again, that's the level of confidence. Generally, this would be the criterion would be 0.05. You would conduct a study. You'd measure the data and compute the test statistic, and then you'd come back up and you'd check it against the level of significance. This is a video of SPSS.